Thanks for the intro, and thanks to Facebook for having us here. And especially thanks for the Beyonce mic. It's a personal life goal of mine to stand on a stage with a Beyonce mic, so super excited. Don't worry, I'm not going to try and sing. So we're from the SwiftKey team. We're part of Microsoft. We're based here in London. And we're here to talk about our sort of unofficial app size guide. First of all, what is SwiftKey? We've got a great video from Partho. He's going to walk us through that.
My name is Partho, and I'm an architect by profession. I live and work in New Delhi, India. I speak, read, and write in 3 languages: Bengali, my mother tongue, English, and Hindi. On my phone, I use SwiftKey keyboard, which means I can switch quickly from one Indian script to another. Previously, I would spell out Bengali using English characters, so some words might mean something totally different if not interpreted correctly. But now we can type Indian scripts phonetically using the English layout, which makes it so much easier to use the language I feel most at home with.
So that's Partho. Who are we? We are Praveen, Bayer, and Olli. We are part of one of many teams within Microsoft who do mobile apps, which may come as a surprise to some people, I don't know. Specifically for SwiftKey, there's 80 of us based here in London, covering all sorts of things from machine learning, the cloud and infrastructure. The 3 of us are specifically from the client teams that work on the Android and iOS keyboard. We just saw in that video there. So today, we're going to be talking about app size and our journey to reduce the size of the keyboard. So we've got Praveen, who's going to be talking about the install size optimizations that we did. Bayer's going to be talking about resource optimization. And then I'm going to be sort of tying that together with some of the SwiftKey specifics. So what is app size? It can mean loads of different things. There's loads of different metrics. There's loads of numbers flying around. We kind of define it as a mixture of these 3 different things. We've got the download size. That's the size that gets reported to users in the Play Store. We've got the APK size, so that's after you do a build, how big is the app, the file that comes out at the end of it. And then we've also got install size, so this is the size reported through the Android operating system. So if your user goes through settings and looks at storage, they can see this number here. And they're all different numbers. Why should we care about this? So specifically for for download size, we specifically care about download size. Because when you look globally, we see that people in different parts of the world have different appetites for app size. So we see here the median download size. The areas in red, the median download size is around 5 megabytes. The areas in green, it's about 24 megabytes. And we can see that SwiftKey, right at the beginning of this journey back in June last year, was bigger than that. So we really cared about download size because we were just so bad at being compact. How about install size? Why do we care about install size? So you've got a user to download your app. It's small, lightweight. A user downloads it. Then we're talking about install size. The Android operating system is really good at telling users to get rid of clutter on their phone. So this happens when a user's running out of storage. When they take a photo, it's going to pop up and say, hey, why not delete some photos or this big bloated app that you have installed? This gets even more prevalent with Android Go. So we see here the Files app. And this is going to be sending notifications to users every month saying, hey, you haven't used SwiftKey this month. You should uninstall it. It's taking up room. So this is all really around just being respectful about a user's storage space, which is going to vary from user to user. And kind of selfishly, it also makes it harder for us to ship SwiftKey on our partner devices if we're a big app. Cool. I'm going to hand over to Praveen now. He's going to be talking about what exactly makes up install size.
Thanks, Olli. So, install size. So I'm going to first talk about what makes up the install size. Consider your APK file. That's the one we are more familiar with, and set it as 100%. Right? Now, when user downloads the app from the Play Store, there's a long installation process going on. So what's happening behind the scenes is the Google Play, so the Android system looks into generates a VDEX file, which is a byproduct of all the DEX code that is part of your APK file. So DEX code is all your Java and Kotlin code. So at the time of building your APK, the Android compiler would generate DEX code, DEX files, classes.dex, or multiple DEX files based on your Java and Kotlin code. And at the time of installation, the Android system would extract this DEX code from the APK and then verifies it and puts it in a VDEX file. That's not everything. And you also have extracted native libraries. If you use native libraries in your app, either directly or through some third-party libraries that you use, and if you choose to extract them, which is the default behavior on Android, they would also be extracted and counted as part of your install size. So when you look at the app size, they always look much bigger than the APK size itself. So this is just part of the story. This is just at the beginning when the user installs the app, right? Now, a few days later, users continue to use your app. Android system uses the ahead-of-time compiler, so it optimizes some code paths which are more commonly used by the user, and generates a new file called the odex file. So this is the optimized dex file, which adds another 23% to your install size, which is generated based on how users are using your app. So this is all that makes up your install size. It's not a single constant that it keeps evolving. And now Google announced this cloud ART profiles for Play Cloud. What it means is it aggregates the profiles to generate the odex file. So the odex file that you see here may actually be generated at the time of installation in future. So now that we understood what makes up install size, so I'm going to talk a little bit about how we went about shrinking install size. Specifically, first, we noticed that the DEX code we write is triple taxed. Once in the APK file as classes.dex, and then again at the time of installation as a VDEX file, which is generated from the classes.dex, and as time goes on, or with the cloud profiles, a odex file. So all the Java code and Kotlin code that you write is essentially triple taxed. And native libraries, if you choose to extract them, are double taxed because you put them in the APK and also extract them at the time of installation. So I'm going to touch mostly about these two topics, how we can decrease size in these two areas without actually changing code in your app, like changing the Java code or Kotlin code, removing anything. First thing, we're talking about decreasing the size of DEX code, right? And the tool we're all familiar with is ProGuard. ProGuard is the go-to. When we started this journey, our ProGuard file looked something like this. Didn't look anything at odd. We were removing some optimizations for whatever reason, and then we were adding some optimizations, which didn't look too suspicious at first. But what we found, one interesting thing we found out about ProGuard's behavior was, when you set up ProGuard with optimizations enabled, it enables all the optimizations it could do. However, when you selectively enable a specific optimization, it decides to disable all the optimizations and enable only the optimizations you asked it to do. So what's happening in the line below is you disable all the ProGuard optimizations and enabled only those optimizations that you listed here. So this was a learning experience for us. So the takeaway is, don't enable specific optimizations on ProGuard because it does everything for you. If you think something is wrong, just disable those optimizations which are not working for you. So it's blacklist them, don't whitelist, because it just makes things worse. Now, digging through the documentation, we found a couple of nice flags that helped with code shrinking. And again, in general, disable as fewer optimizations as you can so that it keeps up with good size. So these 4 flags that you see here are the default flags that are disabled as part of the Android standard ProGuard file. An interesting observation here, you can call it a micro-optimization, is that the last one, code simplification arithmetic, was disabled in Android, all versions of Android, because it enables you to run your app on Android devices 2.0 or below. So you don't actually have to disable it if you're targeting any device above 2.0. We don't, so you can disable that. You cannot disable that. And yeah, so this whole exercise helped us decrease our DEX count by 11%. We went from multi-DEX to single DEX. And the size of our DEX code by 9%. So there's it. There you have it. ProGuard actually can help if you're using it, if you were using it correctly. And another tool we have recently come up from Google was R8 compiler. It promises some very good code shrinking for Android. We tried it out, and it did decrease the size for us. We gained about 1.3 megabytes, flagged by our own internal tools in our install size, which was good. However, the same tools also flagged that did increase the core load of our app time, the core load time of our app by 29 milliseconds, which wasn't ideal. So we decided not to use this particular space gain. But in your case, maybe you could actually gain something there. So it's something to explore. R8, I would say give it a go. And I mentioned about native libraries. So I talked about extracted native libraries specifically. So this is two flags, one in the build.gradle file, which tells you to not compress the native libraries in the APK, which means your APK size would be slightly bigger. The download size may not be as big because Google Play already compresses it at the time of download. And you can also say don't extract it. So when you're using the native libraries, you can use it straight from the APK file without extracting it into a new location and taking up more install space. You may not be using native libraries, but you might still want to look into this because there's a lot of popular libraries like Fresco, TensorFlow, and Letho, which is the previous talk, which does use native libraries. And the default behavior on Android in general is to extract native libraries. And another thing we want to highlight is the SO loader is a library from Facebook used in Fresco and Letho. The default behavior here is to extract native libraries, even though you mentioned these flags in your manifest file and build.gradle file. So it's something to double check that you're not extracting native files. Yeah, that's about wraps up what you could do in decreasing your DEX code without actually removing your Java or Kotlin code. Now I'm going to hand over to Beya, who is going to talk to you about resource file reduction.
Thank you, Praveen. So the first thing to say about the app resources is that it's very easy to leave something unused there, strings that you're no longer using, images that you're no longer using. And both ProGuard and Gradle together can get rid of those automatically, so you don't have to worry too much about them. But there's also a lint check that allows you to find the things that are unused so that you can remove them. However, many of them, you do need them, and we look at ways of making them smaller. So first thing we look at was images. We were using PNGs for images, which is not a very efficient format. And then we found out about WebP, which can be up to 25% smaller without any quality loss, and even smaller if you can handle some degradation of the images. We could have used SVGs as well, which are smaller, and you can just get one file for all the different screen densities. The problem with them is that they can be slower to render, and not all PNGs can be transformed into SVGs. And it's also quite hard to transform the ones that can be transformed. For WebPs, however, you just have to right-click on the drawbar folder and then click on Convert to WebP, and it automatically transforms all of the assets, all of the images to WebP. We did that, and with just 2 clicks, we removed 2 megabytes of the install size. Another thing that can take up a lot of space are translations. When we have all of our strings and the translations, they get compiled into the resources.arsc file. And they are in a structure array matrix, which has a row per string and a column per language. It's very intuitive to think that if we have a string translated into 2 languages, we will have those 2 strings somewhere in that shape that you see in the file. What is not as intuitive is to know what happens when we add a library that has some strings as well. For example, if a library has 1 string only in English, it actually adds 2 items to this matrix because it adds a row and it has the string in English and then an empty space for other languages. And if the new library also adds some new languages, then we're adding both rows and columns, and these columns will mostly be full of empty stuff, which is not a very efficient usage of resources. There is a way of avoiding that with that Gradle option there. You can tell it to only include the translations for the languages that you support. and that removes columns of the matrix, so it's smaller. When we did that, we reduced it to 72 languages, which is not a very reduced number, but that's the ones we have. And that took another 1 to 2 megabytes of the install size. This is not very useful now that there is dynamic delivery and app bundles, which is what we're going to talk about next. So dynamic delivery is the new app serving model from Google Play. Before that, the easiest way to distribute an app was to create an APK that contained all the resources that any user might need. Developers build one APK with everything, put that on Google Play, and then that goes to all users. So every single device has a lot of stuff that it's not going to use because it's not applicable for that device. So then we moved to multi-APK, where we could specify different APKs for different configurations. And we used that to have one APK per API we support. This made them much smaller. Both the APKs and the install size were much smaller. And we could have specified more things, but we decided to stop there because that was the biggest gain. And if you think of the 3 APIs we support times the 4 screen densities that we support times the 72 languages that we support, that was a number of APKs that no one wanted to manage or test or upload or anything. It looks like there was a common problem, so dynamic delivery solved it. Now we can create just one Android app bundle that contains everything. We put that app bundle into Google Play, and Google Play is able to build APKs based on that app bundle. So it will create one base APK with the core of the app, and one configuration APK per API, one configuration APK per screen density, and one per language. So every device only will get the APKs that it needs, any combination of them. And also when its configuration changes, it can pull the APKs it needs from Google Play to get the right language, for example, when the locale changes. Doing this wasn't a massive size gain for us because we were already doing multi-APKs for APIs, but it still allowed us to reduce the download size per 3 megabytes. And the install size per 80 megabytes, which was that was a much bigger thing. This is a GIF that shows the process, and you can see how it's much quicker, much more efficient to just get what you need for one device. The other thing that dynamic delivery allows us to have is dynamic features, which are parts of the app that you can only download when you need them on demand while you're running the app. And that looks very promising, but we haven't found a good usage for it, so we are not using that yet. But it can be a good way to reduce the size further. And now I'm going to leave you with Olli for some final thoughts.
Thank you. OK, so we've shown a whole bunch of different things that we've done within SwiftKey to reduce our install size that we think will be really generic and should work for the majority of apps. The apps that you guys develop. There were some additional specifics that we did for SwiftKey. So actually, a minority of our users speak English US now, so it made sense to remove the English US language pack that was built in. The other thing is we have so many different keyboard layouts. So these are all XML files. We have layouts for all of the different possible keyboard layouts, and then we have that times by tablets, times by phones, times by portrait, landscape. We offer split mode in SwiftKey. We have floating mode, compact keyboards, and they all have XML files. So a huge number of XML files. It's probably not as applicable to most apps out there. But we found turning that into a sort of proto-buff style data file really helped reduce the size of those layouts. I'm going to talk about how all of these different approaches that we've taken kind of feed into a bigger picture. The numbers that we've been mentioning so far, 1 megabyte, 2 megabytes, 3 megabytes, seem quite small, but they actually do really add up. So back in June, this was our release of 7.04. It looked like this. This was the distribution of all the different components. And then when we released version just before Christmas, we can see those savings starting to come through for users. So we can see our Java code reduced slightly there. We can see the graphics reduced as we changed PNGs to WebP. We see that our keyboard layouts went from about 9 megabytes of Android binarized XML to about 3 megabytes of protobuf. We can see that our translations reduced slightly, and we can see our native code starting to reduce as we stopped extracting those native libraries. just to really recap on what Bayer was talking about with the app bundling, when we released app bundles, we saw an even bigger decrease in the sizes. So now we're really looking at those translations being much, much smaller. In most cases, it's around about 1 megabyte for the resources ARSC file now with app bundles, whereas before it was about 9 megabytes. So quite a huge reduction in that area in terms of install size. Again, we see graphics reduce, and the native code would reduce if we weren't already splitting by ABI. So it does. It all adds up. And we can see the sort of headline figures here are really, I'm quite proud of these numbers, actually. So we see that the download size reduced by 50%. So we went from 28 megabytes all the way down to 14 megabytes. And we can see that the install size for our end users is down by about 40%. So that's from 82 megabytes all the way down to 48 megabytes. These things also have impact in terms of the organization, in terms of the business. And we can quantify that. So we can see as the app download size has been decreasing, we can see that users landing in the Play Store in Indonesia, those users then choosing to download SwiftKey went up by about 5%. So Google's research here said that we should be expecting about a 1-2% increase in Indonesia, India, and Brazil. We actually saw a 5% increase for Indonesia, which is really cool. Less of an increase in India and Brazil, but that's how it goes sometimes. I think this is really cool as well because it shows that the relationship between app download size and conversion rate is not linear. So if we reduce the download size to 0 megabytes, the conversion rate is not going to go to 100%. So it's nice to know we've reached the point where we've done enough. Cool, that's kind of my wrap up. Thanks for listening. We'd love to take questions.
Right, any questions, anyone? Just throw it. Come on, there's going to be a question somewhere. Yes.
So I have a question about app bundles. So how do you test your APK? So do you only test it through the Play Store, or do you still assemble your own APK for testing it first? So when you send a build to QA, for example.
So we have done both things. We are still building our APKs that we distribute internally, and then we install them and test them before releasing. And the first time we used Android app bundles, we put the bundle in our internal Play Store and then got everyone to download through it to see that they were getting what we were expecting. And from then, we are trusting Google Play that the thing we put will transform into the APKs that should be transformed into.
So did you ever find any issues where there was a difference between the APK and the AAB in the end?
No, to be honest, we've never had any problems with that. All the testing was fine. All the testing said it worked as it should. And I don't know of anything that has come up after that.
Cool, thanks.
Oh, you just put your hand up first. I'll come back to you there.
Good
Cool.
catch.
So we are talking about a keyboard, and I'm a bit surprised. Why do you need 40 megabyte?
Well,
So we're talking about install size there. 40 megabytes of install size.
That's fine, but you're not displaying, I don't know, high-end graphics or whatever. Just curious, where is your size? What are you doing?
yeah, do you have the slide?
So yeah, we can bring the slide back up with the pie chart. I mean, I don't have numbers for Gboard, and I don't have numbers for the other competitors in TouchPal off the top of my head. I know that we're competitive with those other keyboard apps. I actually think we're smaller than TouchPal, we're smaller than Swipe. I think we're actually maybe smaller than Gboard at the moment, but potentially slightly bigger than the version they've optimized for Android Go. So we're kind of middle ground on that one.
Don't get me wrong. I never made a keyboard. I'm just a bit surprised. That's it.
Yeah, I mean, it's unusual. We normally get a question like, why does it take 80 people to make a keyboard? It turns out there's a lot of languages out there. So yeah, I mean, it's a valid point. I think we're kind of, I think maybe it's just surprising that Android apps are so big in general. Some of the stuff that Praveen was talking about, like the actual DEX code was about 10 megabytes, which comes as a bit of a surprise to us as well. But that's just the amount of code that we need for a modern keyboard.
Do you maybe have a line number of code that you have?
Yes, 200,000 Java lines of code.
That's something.
Yeah, we support 350 languages. We have 200 themes. We have about 367 keyboard layouts. We have 14,000 unit tests. I don't know. This is the sort of scale that we work at in the code base.
Cool. Thank you.
Just to add on to that, our graphics are actually quite small. The most of the size is coming from the Java code and the native code, which is our prediction engine. So, just add on to that. It's not big graphics, yes.
So you mentioned that it's good to not good, but we can disable extracting the native libraries. Does that have any impact of performance or anything like that?
Yes, it could have a slight impact on performance. Like we said, every time we make a change, we measure it ourselves to make sure we're not losing on performance. So R8 had impact on performance. But we didn't see any significant numbers on the performance when we stopped extracting the native libraries. But I would advise to measure it. But I don't imagine significant effect on the performance because the file is not compressed in the APK file. So we're doing two things, not extracting and also not compressing. So I think those things kind of add up, is what I would say.
Coming over.
So I might be wrong here, but if I'm not mistaken, if you do use Android app bundles, there's no APK file anymore, so you cannot sideload an APK anymore. So since you can't do that, have you seen a decrease in the number of people who do sideload your APK for those users who don't use the Play Store?
I think that's a great question. I don't know if we track that internally, do we?
I'm not sure I understood the question. So you can generate both the app bundle and the APK from the same code. So then you have both things for the same code.
Okay.
I think, am I interpreting the question right when we're saying, so we can generate APKs from the app bundle, but I guess your question is around somebody like APK Mirror can't access the AAB. Yeah, so it's not something that we actually track or quantify or have any sort of statistics on. Although, interestingly, crash rates dropped, so I don't know, like, maybe.
So APK Mirror actually announced that they're going to support app bundles soon, I think.
Oh.
Okay.
Yes. just saying, we did notice one of our teams does an end-to-end testing where we download our own APKs from APK Mirror sometimes. And we couldn't find the APKs starting when we moved to app bundles. And that's when we figured out yes.
Okay, yeah, that answers my question. Thank you.
Hi, my question is, I presume you have some code to deal with like text completions and machine learning, the user behavior, how they type. And is that logic part of your bundle, or is actually a cloud-based machine learning?
I think that's a great question.
Yeah, so you mean the part that allows users to, the intelligent part that gives users the predictions and corrections?
Yeah, that's right. Yeah.
Yeah, so that is handled by a different team. So for us, that is a library, and yes, they do that separately, and they train it separately. I don't really know how they do it.
Because you use it as a separate library, but when you bundle it, do you know that actually part of that is part of the code, and when the size of it? And
It is a native library that we use, so it's one of those that goes in, and we have a version per API, and we have, it goes into the bundle, and then you can distribute the right one to the right device. But we don't do much about it. We are a client for them. We just get what they produce, and we use it. I don't know if you know any more details about them, about how it's built.
I don't know specifics, but I would say the engine is about 4 megabytes, and that handles all 350 languages that we support, and that does on-device training. So as a user uses the keyboard, it will improve the language model. We pre-build language models in the cloud. We do that we collect a huge corpus of data from trawling the web in a certain language, trying to find web pages and other content, tweets, whatever we can get our hands on, and then we build a model that we distribute to the device. That's roughly about an extra 2 megabytes for most of the sort of standard Latin character sets. They get a bit more interesting with other character sets. I don't know if that answers your question about the sort of app size specifics of that.
Yeah, cool, thank you.
Cool.
So you have so many languages in the keyboard. How do you make sure that all the languages are up to date, and what is the process when you add or remove strings, and how do you manage them?
Oh, that's an interesting question. I guess there's 2 halves to that.
Yeah,
there's the sort of app translations, where we translate the app to 72 languages, and then there's the languages part where we support 350 or so languages. So the translations that are built into the app, we work with a translation service. We send them a copy of our strings. They send us back the translations for them. And so it's a case of putting the XML files in the right folder before we do an app build. For the language models specifically, every app update, which is about every 2 weeks, we do query the server and say, is there any updates to the language models? But that's handled by this native library, and they write it in a way where there's backwards compatibility. So it doesn't matter if a user happens to update SwiftKey and then loses internet connection. We'll just continue to read the old version of the language back, the language predictions model.
All right.
No. Any more questions?
Hi, so what can be the next step to decrease the app size again? Because you have already improved the app a lot, so what else can you do?
Dynamic delivery, I would say. So one thing we haven't explored was the dynamic delivery. So you could, if you can identify parts of our app, or you identify parts of your app, which you notice that most people are not using, we can figure out if a nice way to extract them into a separate module, which is delivered on demand. Logically, that's the one I could think of. Maybe there's other ways.
Okay, thank you.
Actually, you have done a great job in compressing the size. One thing I was just curious about, when using the ProGuard rules, do you prefer the keep annotations or prefer specific ProGuard rules written directly in the ProGuard files? Like, for example, if you're using the Kotlin classes, do you use the keep annotations in those specific classes, or do you write specific rules in the ProGuard files?
So we do a bit of both. We use the keep annotations, and then just because we said keep annotations doesn't imply that ProGuard would keep them. You would still have to tell ProGuard that when I say keep annotation to any class, keep it. So you need to do a bit of both. So keep annotations is a way of giving you yourself an interface where you can just annotate different classes to keep it, rather than explicitly saying each class in your ProGuard file. So I would say they work together rather than independent of each other.
Okay. Yeah.
Any more questions, gang?
Thank you very much, and congratulations on your endeavors, at least. And I wanted to know if, for example, if your concept was very upscaled, okay, in terms of Android apps, possibly, because right now we've got an issue with certain apps which are quite bloated and spaces running short everywhere, more or less. What would you do next? What are your next plans, basically, possibly, for even slimmer sizes?
So beyond dynamic delivery,
Yes.
the next steps, I think it really depends on the app that we're talking about. So like SwiftKey, we feel like we've hit a good ground. Like we don't really want to set the goal of making the app size 0 megabytes because it's not achievable, and at some point there's going to be diminishing returns. So I think having looked at the sort of conversion rate in Indonesia and seeing that start to flatline across Q1 of this year, I think we've reached that point. I mean, I guess more generally, everybody's app's going to be slightly different, right? Like, there's going to be apps out there that are maybe games or something, and they've got loads of assets, and even applying these sorts of techniques is not going to get it down to 14 megabyte download size. I think it really is. It should really be like user driven. I think as soon as you apply the techniques that are going to yield the biggest results first. App bundling is a great place to start. And then the areas that Praveen pointed out that are getting triple taxed and double taxed, like DEX and native libraries, I think they're good places to start. But it's just the start of the journey. We did this the beginning of June. We started this last year, so it's taken 6 months to get to this point.
But thanks a lot anyway. Congratulations again.
Thanks.
Thank you.
Right. Probably got time for 2 more questions. One here.
So you've noticed that increasing size will generally reduce the number of your users. So how do you decide if a new feature is worth the size that it will bring into the APK?
I think that's a great question, and one that I wish one of our product managers was here to answer. I think you only really know how valuable a feature is going to be once you've shipped it to users. Like, you can build something, and it can be, you think it's wonderful and amazing, and you ship it to users, and users just don't get it, or don't like it, or it's not quite the right thing. And so it's really, I don't know, I think we managed to walk a delicate line at SwiftKey of sort of like, you can't ever promise a certain return from a feature. You can't ever go in and be like, we're going to build this feature because there's going to be 73 users that are going to use it 27 times each, and therefore it's worth an extra 1.7 megabytes of storage. Like, we can never have that conversation. Certainly with the things where we've, like the English US language pack and things like that, when we do ship a feature and we see that it's not getting traction and is using up a lot of storage space, then that's the point at which we say, actually, let's get rid of that, or let's change that, or turn that feature off. So I guess more reactionary than proactive culling of features.
To add to that as well, I think we have now shifted that conversation. So instead of saying, should we add this because it's going to increase the size, the conversation is more, should we make this a dynamic feature? And there will be something that will make a dynamic feature for the first time, and then hopefully we'll go on making them.
Last question, anyone?
Is there a question over there?
Over there.
Thank you.
I assume you use Kotlin. Do you use it?
Yeah, you assume correctly.
Did you measure size impact of Kotlin?
Oh, interesting. No, so we're still in a process of adding new code in Kotlin. We haven't converted any of our existing Java code into Kotlin because it's a bit risky given the change in some of the semantics. No, not yet. But if anybody does, then they can come and give a Lundroid talk in a few months' time.
Yes. Right. Right, then we have. Oh, blimey. We'll call it there then, please. Round of applause. Thank you very much.
Thank you.
Thanks, guys.